Let's do the first one mean t-test together. Larson was trying to decide whether to use a new racing wax for cross-country skis. He decided that the wax would be worth the price if he could average less than 55 seconds on a course he knew well. So he planned to test the wax by racing on the course 8 times. Based on the 8 times listed, should he buy the wax? So in statistics, what this is really saying is, at the 5% significance level, do the data provide sufficient evidence to conclude that the wax will improve Larson's average course time? All right, so let's start breaking the problem down. The first step in phantoms is to really just look at what they're asking us to do in terms of the parameter. So our parameter here is the mean, and we're going to test the claim that the mean course time is less than 55 seconds. That's going to lead into our hypotheses. So our null hypothesis is that the mean, or mu, is equal to 55 seconds. And the alternative hypothesis is that mu is less than 55 seconds. Then we have 3 assumptions and conditions to check. We have the random sample, normal large, and then what type of standard deviation we have. So let's take a look at those. I didn't see random sample stated, so I'm going to put a star there and mark that as not stated. The sample size is 8, so we definitely don't meet the large criteria for the central limit theorem. So we'll need to look at that normal probability plot. And then I calculated this sample standard deviation earlier as S equals 7.03. So I didn't see a population standard deviation listed anywhere. So that was my clue that I needed to calculate the sample standard deviation to use that. And so that's what tells us we're doing a one mean t as in tiger test. All right, so let's go over to Excel so we can look at that normal probability plot and then calculate that sample standard deviation so we can double check my work here. So I'll see you on the chapter 20 data sets for ski wax. All right, so here are our chapter 20 data sets, and you want the tab that's labeled ski wax. And the first thing we need to look at is that normal probability plot. So you want to go to the data ribbon and then click data analysis. And the choice you're looking for on this list is the one that says regression. So we'll choose that. And then remember that this is where the variables are reversed. So they want the y values first, which is usually kind of backwards from how we think that might be. So we'll highlight those times, and then they want the x values next. So those are just the observation numbers. Make sure that you have normal probability plot clicked at the bottom. And then there's our normal probability plot. So that looks really, really good, nice and straight, which is what we want. So I think that condition of normal is satisfied by the normal probability plot. And then let's get our sample standard deviation and make sure I calculated that right. So STDEV and highlight our data. So there's our 7.03. And then we also know that we're going to need our sample mean for our test statistics. So let's get that while we're here. And that command is using the average. And so I get 53.1 for my sample mean. All right, so we're ready to do our test statistic and get our p-value. So I've written those numbers down, and what I'm going to do is switch over to those Excel statistical calculators, those spreadsheets that I built for you with all of the hypothesis tests and confidence intervals, and we'll go work from there. All right, so here are the Excel statistical calculators, and you're looking for the tab that says one mean t-test, chapter 20. And then once you've found that, we're going to start by putting in x bar sample mean. So we calculated that from our data, that's 53.1. The mean mu, that's your null hypothesis, and that was that it was less than 55 seconds. So we'll put 55 in for the mean. The standard deviation, we also calculated that from our sample, that was 7.03. And then our sample size was just those 8 runs. And so that gives us a degrees of freedom of 7. So you just subtracted 1 for that degrees of freedom. So our test statistic is negative 0.764. So we'll write that down. And then our alternative hypothesis was that mu is less than 55. So it makes this a left tail test. So we want this 0.234 as our p-value. So we'll write that down, and then I'll meet you back over on the spreadsheet to finish up the conclusion for this. All right, so here's where we left off in terms of filling this out. I'm going to circle that word normal because we did look at that normal probability plot, and this is our one mean t-test. And then hopefully when we were working in Excel, you wrote down that that test statistic was negative 0.76. with a p-value of 0.234. So that's about 23%, which is definitely bigger than our alpha of 5%. So if p is bigger, we do not reject our null hypothesis. So our conclusion statement is, with a p-value of 0.234, or 23.4%, at the 5% significance level, we do not have sufficient evidence the mean course time was less than 55 seconds with the new ski wax.